Good day, geometry students, and welcome to 6.6. This is the Law of Sines, and much like it implies, you will be using the sine function. Now, the biggest difference here for Law of Sines versus the right triangle trig versus, the SOHCAHTOA stuff you were using before is that the SOHCAHTOA was all in right triangles. Okay, meaning that you needed a right angle somewhere in that triangle in order to do that. Okay, that only works in right triangles. In Law of Sines, okay, these only work in non-right triangles. Okay, so you cannot use Law of Sines with right triangles. That's a big no-no. Okay, you cannot use Law of Sines with right triangles. So let's kind of talk about and figure out what is the Law of Sines and how it works. Okay, so as I said before, this is you cannot use on right triangles. That's a big one. And the relationship you're looking for is you need one side and the opposite angle. Okay, so one side and the opposite angle. So if we look here, so we've got the capital red A and the opposite side, lowercase a, the capital B and the lowercase b, and the capital C green and the lowercase c here. Okay, and here's kind of all it says, is that the sine of an angle over its opposite side is equal to the sine of any other angle over its opposite side, is equal to the third angle, sine of a third angle over its opposite side. So let's kind of, this is kind of what the big Law of Sines says. Let's kind of put it into practice, because you don't have three problems that you're trying to solve. Okay, most of the time you're dealing with only two, okay, and then just solving a ratio. So look at kind of what we're talking about here. So if I look here, what I need very, very much is one angle and its opposite side, which is what I have. Okay, so I've got this, and I've got its opposite side. Okay, so now I need to figure out the length of C. This is going to be slightly problematic because I know that this length is C, but I don't know what this is. I don't know what that opposite angle is. I don't. Okay, that's a problem. So what I do know that this is 15. So if I know that this is 15, I can actually figure out this angle B right here. Okay, and all I'm going to do is use Law of Sines. So here's kind of how it works. I know that the sine of 42 over 12, that will be equal to the sine of B over 15. Okay, so the sine of an angle over its side, sine of an angle over its side. Okay, so now it becomes a ratio problem. So I take 15 times the sine of 42, and that's going to be equal to 12 times the sine of B. Now pay attention, because this one, there's a couple little tricks you need to be made aware of. Okay, so first off, 15 times sine of 42, that's an actual number. So 15 times sine of 42 becomes like 10.037, and that equals 12 times the sine of B. So now I'm going to divide both sides by 12. And in doing so, I get this weird answer, 0.8364, and it goes on. And that equals sine of B. Okay, so now to figure out what B actually is, this is where I do that weird sine inverse thing that we did before to solve for an angle. So I'm going to take sine inverse of my answer, and I get that answer to be 56.76. Okay, so that means this angle up here, is 56.76 degrees. Okay, so now why do I care? Why is that important? Well, it's important because I really, really want to know what this angle is right here, this angle C. Okay, and to do that, I can take 180 minus 56.76 minus 42, and I get this angle to be 81.23. Now, let's round it, 81.24. 81.24. Okay, so now I can set that up again. Okay, so I can set it up again. I can go sine of 42 over 12. And that's going to be equal to the sine of 81.24 over C. Okay, now I know I'm starting you off with a very difficult one. I apologize for that, but it's worthwhile here. So I take C times sine of 42. And that will be equal to 12 times sine of 81.24. Divide both sides by sine of 42. So then you can C equals, and you can put all of this into the calculator almost at once. So I mean, if you take sine of 81.24 times 12 divided by sine of 42, you end up with 17.72. So that's how long that answer is. That's how long that side is, 17.72. Okay, now that's a complicated one. This would be an extensive one. This would be, this one would take you a while. This would be a more difficult problem that I would ask you to solve. Okay, let's look at number 2. I believe that one's going to be a little bit easier, and it is. So let's look at number 2 here. So number 2, we've got 125 degrees and 100. Over here, we've got x and 60. Okay, so we're trying to figure out angle x. So I'm going to set it up the sine of 125 over 100. All right, that's kind of everything I'm basing off. That's going to be equal to the sine of x over 60. So now it becomes a matter of cross products. Equals that. Okay, just going diagonally. That's what I end up with. So now solving, I'm going to divide both sides by 100. And again, I can throw all this in the calculator at once, and I'll get something like really, really weird. And then to solve it, I would take the sine inverse of all of this to get my answer. Okay, so I'm going to take 60 times sine of 125 divided by 100, and you get like 0.4915, okay, and the decimal keeps going. So you take sine inverse of that, and you get 29.44 basically for an angle measure. So that makes sense. That's about what my answer should be, 29.44. Okay, but here's the setup is the big challenge here, making sure that I got that in the right location. Okay. Sometimes you will see the law of sines set up like this to where they put the side measurements on top, and that's fine. Either way, I mean, for me, it's a little easier to set it up this way, but that's my own personal preference. If you set it up here, that's perfectly fine. That's perfectly fine. Either way is there. Okay, so now let's take a look here. So we have the town of Allen, the town of Centerville, and the town of Brickton. What is the angle Allen creates with Brickton and Centerville? So we're looking at what is this angle right here. So what I need is I need an angle and its opposite side, which is what I have here with Brickton. And I'm trying to figure out that angle right there. So my setup is going to be sine of 63 over 512. That will be equal to the sine of x over 560. So that's going to be my setup. So then doing some multiplying, I get that. So I'm going to do some division, divide by 512. So I'm going to be left with sine of x equals all of this. And you can do some calculator mashing. That's perfectly fine. You're not gonna damage it by doing everything at once. Just make sure, check your order of operations for sure. Absolutely. So when you do that, you get 0.9745. Okay, again, rounded off. The decimal keeps going. So again, I want to take sine inverse of sine of x, because that will leave me with just x. So now I take sine inverse of the decimal, and that's going to be 77.04. That's my answer. So that's going to be the angle that gets created there. And that's it. And again, all this is in the setup. Okay, so a couple more examples. Let's look. So they want to find DEF, find E to the nearest 100th. So they want to figure this out. Okay, again, I'm looking. I have an angle here. I have the opposite side. So that's going to be sine of 54 over 7. And that's going to be equal to the sine of 67 over E, because E is what I'm looking for. Okay? So now that's going to be 7 times the sine of 67, and that's going to be E times the sine of 54. So now to solve, I'm going to divide by the sine of 54, because that goes away. That becomes a big 1. So E is going to be equal to all of this stuff on the left side. And I can just kind of go calculator mash on it. So multiply 7 times the sine of 67, then just divide by the sine of 54, and I get 7.96. They want it rounded to the nearest hundredth, so that would be 7.96, and that's my answer. Okay? Which isn't too terrible. It's not too brain-breaking. A lot of this battle's in the setup. So find DEF, the measure of F to the nearest whole degree. So they want one more with measure F. So you want to know this one. All right, well, I know that 50 and 12 is there. So I would go sine of 50 over 12 will be equal to the sine of angle F over 8. So again, it is absolutely a ratio problem. So you go diagonally. So divide by 12, divide by 12. So 8 times sine of 50 divided by 12. You get 0.5106. So then I want to take sine inverse. So sine inverse of that should be 30.71 equals F. So to the nearest whole degree, I would call that 31 degrees. Okay. Okay, so play around with 6.6. Make sure you do the quizzes. We are nearing the end of the unit. There's only one more section left. And then you're working on your review. Okay, I look forward to your questions. Bye-bye.